Okay, this is the final section of Chapter 3, Elasticity, and let's do a little bit of a quiz. Which item or service is elastic and which one is inelastic, and how do you know? Well, let's see. Let's get our pen out. Which one do you think is elastic? Which one is the need? Or which one is the want if it's elastic? Hopefully you guessed the car. The car is elastic, and gasoline is inelastic. With a car, there's more substitutes out there, and with gasoline, since gasoline is needed for the car, once you buy the car, you have to have the gasoline. Not nearly as many substitutes for gasoline, although there are getting to be more. And when there are going to be more, gasoline will be cheaper. But as it is now, we all need gasoline for a car. So gasoline, inelastic, car, elastic. All right, let's go to our final method of calculating elasticity, which is called the total revenue method. Total revenue is the amount paid by buyers and received by sellers of a good. So it's the amount of money received, does not take into consideration cost. It's computed as the price of the good times the quantity sold. And here it is, P times Q. Graphically, as we can see in the next slide, graphically, total revenue is the rectangle underneath the demand curve corresponding to price and to quantity. So here we have a price of 4, quantity of 100. That is total revenue of 400. Now, to use this total revenue test for elasticity, there's total revenue. Here it is. We can there's different ways to do it, but the way I tend to do it is via a table. Total revenue test for elasticity. If you increase the price and you get an increase in total revenue, you are having an inelastic demand. If, on the other hand, let's see which one is next. Okay, you have a decrease in price, increase in total revenue, it's elastic. Increase in price, decrease in total revenue, elastic. Decrease in price, decrease in total revenue, inelastic. And this total revenue test is used by people all the time. It's really kind of a trial and error type of a thing. If I increase the price of my tuition and I'm assuming that I'm going to be making money out of that, I am in fact assuming my demand is inelastic. If, on the other hand, I'm dropping my price hoping to get total revenue, I'm assuming my demand is elastic. If I get it wrong, my increase in price gets a decrease in total revenue, I could be having an elastic demand for that good. Let's say that I thought my good was the bomb, my particular brand of toothpaste or my type of coffee. I raise the price, and it turns out that consumers don't feel that way. I have, in essence, determined that my demand is very elastic in nature. Similarly, if I decrease my price, decrease in total revenue, inelastic demand. So for gasoline, if I want to be profit making, I do not want to drop my price if I don't have to, because if I do, I will have a decrease in total revenue. It will be a greater decrease in price relative to the increase in quantity demand, inelastic demand. Hopefully, is that along a demand curve, as price goes down, elasticity becomes less and less. In other words, the cheaper the item, the less elastic that is going to be. Cheaper items have less price responsiveness than expensive items. Vice versa, as the price goes up, demand is going to be far more elastic in nature. And as a result, price goes up, people are going to be making more choices to not consume your item vis-a-vis other items. So the demand curve shows elasticity, and elasticity definitely changes along a linear, i.e. straight line demand curve. All right, on to the last two measures of elasticity. Income elasticity of demand is another type of elasticity with respect to income. Income elasticity of demand measures how much the quantity demand of a good responds to a change in consumers' income. It is computed as the percent change in the quantity demanded divided by the percent change in income. So income is our independent variable here, not price. Computing income elasticity, it's the percent change in quantity demanded over the percent change in income. Now the goods in question, as I talked about in Chapter 4, a normal good. As the income goes up, you will buy more of the good. The income elasticity is positive. The signs of the equation are going in the same direction. Increase in income, buy more of the good. Inferior goods, income elasticity is negative. So if my income goes up, I'm going to be buying less of the good in question. So the signs are going in the opposite direction. My income goes up, I'm going to be buying less of the good. So higher income raises the quantity demanded for normal goods, but lowers the quantity demanded for inferior goods. Finally, we have cross-price elasticity of demand. There we go. And the formula, and it's with regard to related goods, elasticity measure that looks at the impact a change in the price of one good has on the demand of another good. So there's the formula down there. It's the percent change in the price of good 1 over the percent change in the price of good 2. If the percent change in the price of good 2 goes up and the percent change in the quantity of good 1 goes up, they are substitutes. If the price of Coke goes up, I'm going to buy more Pepsi as a result. Those two goods are substitutes. If it's negative, if the price of good 1 goes up and I buy less of good 2 as a result, the goods are complements. So as the price of movies goes up, I buy less popcorn as a result. Those two goods are related to each other, those two goods in a complementary way as opposed to a substitute kind of a way. And this is a nice measure to show the elasticity of substitutes and complements. Now for this too, we look at the signs. We're not as concerned about the number. Positive sign is substitutes. The arrows are going in the same way. Increase in price, increase in the quantity of good 1. Negative, the signs are going in the opposite direction. Increase in the price, drop in the complementary good. Alrighty, I do believe that ends